continue our quest with exponential functions, we are going to look at how we can solve an exponential equation for x when it's in the exponent using what we call the equal base method. So this equal base method is based off of pretty basic facts. Like if you look at number one, if we have 5 to the x equals 5 to the 8th, we have an equal sign, so the left side has to equal the right side. We have our base of 5 here, it's the same as the base of 5 here. So guess what? If those bases are the same, then those means the exponents have to be equal to each other. So as soon as we know the bases are the same, those bases ultimately cancel out, and we can just set our exponents equal to each other, and that would give us x equals 8. So our goal for each of these is we're trying to rewrite the larger base as a smaller base and get equal bases. Sometimes we may need to rewrite both of the bases as a smaller base, but we'll get to that shortly. So, for the example 2, we have 5 to the 3x minus 6 power equals 125. So our smaller base is 5. So we're going to try and rewrite 125 as a base of 5. So we're thinking 5 to what power is 125? Well, we know 5 to the third is 125. So I'm going to keep my left side the same, and instead of 125, I'm just going to rewrite this as 5 to the third. I didn't change anything, I just, instead of writing 125, I wrote 5 to the third. But now if you look, we have equal bases here. So now those bases are both 5s, those bases cancel out, and we can just set our exponents equal to each other. And now it's just a regular linear equation that we can solve. So we would add 6 and divide by 3. So that would give us x equals 3. Now example 3 is a little bit trickier because for example 3, my smaller base is 4, my larger base is 8, but I cannot rewrite base of 4. 4 to no power gets me to 8. So 4 to the first is 4, 4 to the second is 16. I can't get to 8 with a base of 4. So what I'm going to actually have to do here is actually rewrite both bases as a smaller base. So that will just make a note here. Sometimes you need to write both bases as a smaller base. So now you're trying to think to yourself, all right, what number raised to a power gets me to 8 and what number raised to a power gets me to 4? So in that case, that base would be 2. So I'm going to rewrite 8 as 2 to the third. Okay, so 2 to the third equals 8. So all I'm doing is rewriting 8 as 2 to the third. There was an exponent of x plus 2 on the base of 8. So my exponent of x plus 2 will still be on the base as 2 to the third. Same thing here. 4 I can rewrite as 2 to the second. And then I have to have the exponent of x minus 3 on the 2 to the second. Now, if you remember a law of exponent, you need to remember law of exponents here. If you have x raised to a power, raised to an additional power, like x to the second cubed, that law of exponent, where you have one base but two exponents, says you multiply your exponents. So that gives you x to the sixth. Same idea here. We have one base, but we have two exponents. So what that's telling me is I have to multiply the 3 times the x plus quantity of x plus 2. So I'm going to have to distribute that 3 to both the x and the 2. So I'm going to end up with 2 to the 3x plus 6 power equals 2 at base of 2, and then I'm going to distribute this 2, the exponent of 2, to the x minus 3. So we have 2 to the 2x minus 6. Again, now I have those equal bases, so those bases cancel out. I can set my exponents equal to each other. And now I'm going to get all my x's on one side, my numbers on the other. So I'm going to subtract 2x and subtract 6. So we get x equals negative 12 for this particular example. All right. Getting a couple more examples here. What happens if we have a fraction? So in this case, I'm going to want to think about what kind of exponent gives me a fraction. Negative exponents move that base to the bottom. So I'm going to say 4. What I usually do is I cover up the top. I'm thinking, all right, 16. 16 I can figure out as 4 to the second, and I can also take 4 to the third and get to 64. So if I'm going to say 4 to the second is 16, 4 to the negative second is 1 over 16. Because remember, a negative exponent takes your base and moves it to the bottom, and then your exponent becomes positive. And then, like I said, 4 to the third is equal to 64, and that would then be raised to the 2x power. Again, once we solve this, we're going to multiply our exponents here, 4 to the 6x power. And so now my bases can cancel out. And we would get negative 2 equals 6x. We divide by 6, and x equals negative 1/3. The other thing we would want to remember is how we can do radicals. Okay, so remember when we do radicals, the square root, this number here, this root is what we call the root or the index, and then there's also an exponent out top. And I'll just call this x underneath here. That is equal to x to the exponent over root power. Okay, so the root is always on the bottom of your fraction, just like the root is on the bottom of a tree. The root is going to be on the bottom of a fractional exponent. So, therefore, I'm going to have this as, I'm going to just keep this as 9 to the x for right now. And I'm going to rewrite this radical, the cube root, as a fractional exponent. So it's the cube root of 3. So 3 is going to be my base. And as I said, there's a 1 on the exponent because there's nothing there, and the root is 3. So this is going to be the same as 3 to the 1/3 power. Now that 3 is on the bottom of the fraction, so what I'm going to do to move it up is I'm going to make that exponent negative. So I'm going to write this as 3 to the negative 1/3 power. And then I need this 9 to become a base of 3 also. So I'm going to rewrite 9 as 3 to the second, which is raised to the x. So I multiply my exponents there, 3 to the 2x equals 3 to the negative 1/3. And then we can go ahead and cancel our bases out. And we end up with 2x equals negative 1/3. We would divide by 2. And we would get x equals negative 1/6. And so for number 6, we just have a base of e. And we haven't talked a whole lot about what e really means other than that number in PERT. But just know it's a base. So the bases are almost the same. It's just that this e is on the bottom. So move that, the piece of e to the top. I'm going to make the exponent negative. And so now I have e to the x equals e to the negative 2x. Our bases are now the same, so they would cancel out. And I get x equals negative 2x. I want to get all the x's on one side. And then I would just divide by 3. So I'm going to get x equals 0 here. So you should try these on your own to see what you end up with. And as you go through this, here you would have to get 3 to the third. 27 you raise 3 to the third. Your bases can cancel. 2x plus 1 equals 3. We'll subtract 1. 2x equals 2. And when we divide by 2, we're going to get x equals 1. For number 8, we have 5 to the third. Our base is going to be 5. 5 to the third is 125. It has to be raised to the x. 5 to the fourth is 625. We multiply our exponents here. Our bases now cancel, so we get 3x equals 4. And we would end up with x equals 4/3. For number 9, we have our lower base of 2, our larger base of 8. So I'm going to rewrite 8 as a base of 2. So 2 to the third equals 8. That has to be raised to the 3x minus 1 power. And that's equal to 2 to the 2 minus x power. Okay, we have to multiply our exponents here because of that law of exponents. 9x minus 3 in the exponent. And then our bases now cancel out. 9x minus 3 equals 2 minus x. We would add x and add 3. So we get 10x on the left, 5 on the right. And when we divide by 10, x equals 1/2. All right, last but not least, I see 1/8 and 64. So I'm thinking a base of 8. I know that 8 to the second is 64. The issue is here is this is 1/8. I wanted just 8. So remember, a negative exponent is going to move to the bottom. So I'm going to rewrite 1/8 as 8 to the negative first, raised to the negative 3x power. Multiply my exponents here. That would give me 8 to the positive 3x power. Our bases are now the same, so they would cancel out. 3x equals 2. And when we divide by 3, we would get x equals 2/3. So that's how we go about solving for exponential equations using our equal base method.